Good evening. There seems to be a lot of debate on Shopsmith forums and Shopsmith Facebook groups as to how much power a Shopsmith really pulls when in operation. In meaning this, I mean, of course, how much current it pulls. We know that the device is rated around 14 amps, but is that really what you're pulling? You know, there's a lot of debate. Can you run this on a 15 amp circuit, or do you need a 20? You know, just really trying to figure out what's going on. So with that, I'm going to run a few tests here today. I have my Shopsmith Mark V Model 520. I have it set up in a RIP configuration. I have a bandsaw on a power stand, and over here I have a Pro planer. So what I want to do is record and look at the actual current draw of each one of these tools while in use. It's one thing to look at the current draw while the tool is just freewheeling, but I would expect that power draw to actually go up when the tool is being used. So to load these tools down, what I'm going to do, I'm going to take this 4x, it's pressure treated pine. What I'm going to do is I'm going to first resaw it on the bandsaw and look at how the current changes based on load there. I'm going to then rip those pieces, or at least one of those pieces, on the table saw, and then I'm going to plane it with the Pro planer. And I think it will really help to shed some light on what's going on in your shop and what kind of circuit you will really need if you want to be effective and work with your Shopsmith without causing problems. Okay, to explain what's going on here with this panel, it is set up to measure both voltage and current. You'll notice there's one voltmeter and two ammeters. The voltmeter is set up to measure across both hot legs, so it is showing actually 250 volts, which is what we would expect in a typical US household. The ammeters are set up to read each leg individually, so anything I have connected to this leg will show up over here, and anything I have connected to this leg will show up over here. Each one of these is representative of the current draw at 125 volts thereabouts, since we're reading 250 across both. For this configuration, I have it set up to where the sawdust collector is going to be exclusively on this leg, and all of my other tools are going to run on this leg. So we shouldn't really expect to see this one move too much once I turn it on. It'll be pretty steady. I did that because this meter likes to stick. You'll probably see me have to thump it once I turn that on to get an accurate reading, whereas this one seems to read pretty well. And so what we'll be looking for is this, and you'll be able to see what that power draw is at any given point, and then we'll be able to calculate based on, you know, current and voltage what the actual power draw is. But for the purpose of this video, we're really interested in amps anyway, because we're talking about a 20 amp circuit or a 15 amp circuit. It would be very rare to hear somebody refer to it as a 1200 watt circuit or an 1800 watt circuit. It's just not the way it's mentioned around here. So anyway, with that in mind, that's how the setup works. I will go ahead and turn on the sawdust collector, and I'll probably have to tinker with this gauge, then we'll get started. As I suspected, that's not particularly accurate. The sawdust collector is not pulling 25 amps. That's better. 8 to 10 is kind of what we would expect. so what can we learn from this? I would venture to say that we can learn a lot. The biggest thing that I would say that we can take away from this experiment today is that the nameplate on the motor doesn't always tell you the whole story. That might be a best case scenario or an optimistic scenario, but in the case of my 520 here, it's rated at 13 amps, but in the middle of that cutting pine, you know, it drew upwards of 20. So if you're on a 15 amp circuit, maybe you've got a few lights on that circuit, or you're trying to run your sawdust collector at the same time, that would easily explain why you have problems. So that just highlights the need for a good 20 amp circuit for running your Shopsmith. If you're going to run it off an extension cord, that needs to be a very heavy duty extension cord. The one I'm using for this here is rated at 20 amps. It is a number 10 extension cord. There is no voltage drop across this cord. You have crappy wiring, crappy outlets, you use those stupid stab-in receptacles, you know, all those things add up against you and are just going to cause problems. The bandsaw here didn't really seem to care too much. I mean, I could see that it may have fluctuated a little bit, but not really that bad. It's supposed to pull about 9 amps, and that seems to be about what we saw. The planer over here is rated at 15 amps, and okay, you would think this is rated at 15 and this is rated at 13, but from what I can see, this pulled a whole lot more power than that did. So yeah, you need to look at the nameplates, you need to figure out what your optimistic values are, but when you're wiring your shop, go ahead and use 20 amp circuits and you'll have less problems in the long run.